Oh, we have my favorite student, good old Anne. So, number one, suppose this mass begins from rest. I would probably mentally underline that VI is 0. If M1 is 3.2 kilograms, there's a coefficient of friction of 0.34, and theta is 58 degrees. Find the time, find the time that it would take the mass to slide a distance of 5.8 meters down the slope. Okay, I would probably say, what does this question want me to find? It wants me to find time. I know that VI is 0. I know that D is 5.8 meters. What else do I need to find time? Well, if I had VF, that would work. Do I know V final after 5.8 meters? Nope. What else could I use to find time? I think I'm going to need to find the acceleration. Good morning, good morning. We're marking our take-home quiz. I think I'm going to need to find the acceleration. So even though this question says find t, I'm going to spend a lot of my time finding a. I'll walk through this though. I think the equation that I would use is going to be d equals at squared over 2. D equals a half at squared. What happened to the VIT, Jack? I know, we're welcoming back. Yeah, okay. And in fact, that means, by the way, if VI wasn't 0, I'd have to use the quadratic formula because it would be a yucky one where there was a t and a t squared. And I could do it, especially if I had a solver. Woohoo! But here, I can actually get the t by itself. I think the d drops down like a domino. It's going to be times by 2, divide by a, and then square root. Okay, that's going to be t. I'll come back to that. Now, how will I find a? This is a job for a free body diagram. Get the obvious one. Now we're on a ramp. Pause. Components. mg perpendicular, mg parallel, color, 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 color. Oh, there's the 90. What else? Are we sinking into the ground like quicksand? Nope. So there's a normal force, the same size as mg parallel. And the question does say there's friction. Which way is friction? I need to first of all figure out which way the mass is sliding. Which way is the mass sliding? Down the ramp? So which way is friction pointing? What if the mass was sliding up the ramp? Which way would friction be pointing? Down the ramp. I can handle it. But meanwhile, and I'm making the assumption that friction is losing. I'm assuming that this mass is speeding up. I'll know I've guessed wrong if I get a negative acceleration. I'll go back and tweak my question, or I could crunch it ahead of time, but I think we'll go like this for now. So who's winning? I think it's going to be mg parallel minus who's losing? I think friction, and that equals ma. Armand, friction is what times what? So it's going to be mg parallel minus mu Fn equals ma. I don't know the normal force. Oh, but look, 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 look. I know the force is the same size as the normal force. It's not mg, definitely mg perpendicular. So I think I can go mg parallel minus mu mg perpendicular equals ma. Oh! Grace, is there an m in the first term? Is there an m in the middle term? Is there an m in the last term? Although I gave you the mass, could I also have given you this question and not bothered giving you the mass? Yeah, it turns out here the mass cancels. And again, I think I mentioned this is why little kids and grown-ups can hold hands on the ski slopes together. The grown-up will have to do a little bit of adjusting because they have a bigger air resistance and we're ignoring that. But for the most part, the mass cancels. 2 lines. Sine. So it's going to be g sine theta minus mu g of cos it is theta There's my acceleration. I got room for one more, I think. Okay. A equals 9.8 sine, what was it, 50 something? 58 degrees. Minus 0.34 times 9.8 cos 58 degrees. Now, if you didn't cancel out the m's, you'll be okay. You'll get the same answer as me. You would just have an m there, and you would also have an over m. So you would times everything by m and divide everything by m, which is why it cancels. So you'll get the same answer, but I'm naturally lazy. Why would I do extra work when I don't need to? 9.8 sine 58 minus 0.34 times 9.8 cos 58. By the way, if we were sliding uphill instead of downhill, friction would be pointing downhill. I would have two winners, no loser. It would be winner plus winner, like elementary sports day, no loser. Do you guys get an acceleration of 6.54518? I'll write 6.5. You know what? I'll probably go, how about 6.54581? That's a good place to round off because there's a 0 there. I'll use my answer button probably, but 6.54518. Not red, Mr. Duke. 6.54518. And now let's use this to find time. Time was equal to 2 times d over a square root. Time was equal to 2 times 5.8, yep, all over 6.545. I'll use my answer button. 2 times 5.8 divided by answer button. Square root of that. Y'all get 1.33 seconds? That's a nice written question in my mind. If you got that, 4 out of 4. Otherwise, I would give you 1 mark if I saw that line. Well, you know what? I would probably actually give you a half mark if I saw that. A half mark for the answer. I would give you a half mark if I saw that. That's 1.5. Half mark for that. That's 2. If I saw you cross out the m's, that's 3. Half mark for the numbers, and a half mark for finding the acceleration. 1, 2, 3, 4, 5, 6, 7, 8 halves. That's 4 out of 4. But if you got it right, I'd give you 4 out of 4, as long as you showed some work. If you just write an answer, sorry, I kind of assume you probably cheated because I would have trouble doing this all on my calculator, not showing anything, so don't do that. Show some work. Ooh, Atwood machine. Ooh, missing mass question. Cool. This is a job for a free body diagram. We have M1G tension, M2G tension. Okay, I know mass 1, so I'm going to write an equation for mass 1. And they told me it's accelerating upwards. Oh, they put that in the picture for me. Well, that's very nice. Good morning, good morning, good morning. We are marking a take-home quiz. So for missing mass questions, our strategy is write an equation for the mass that you know. Find whatever you can. Tension in this case, and then go write an equation for the mass that you don't know. If there's more than 1 m, we use that grade 9 trick to turn it into just 1 m. So let's see. Who's winning? Tension minus M1G equals M1A. This is not a swappy dance. I'll just plus the M1G over. Tension equals M1A plus M1G. It's going to be M1 3.9, A 2.6, M1 3.9, G 9.8. Tension equals 3.9 times 2.6 plus 3.9 times 9.8. You get tension 48.4? Is that correct? If you got that, 2 out of 2. Otherwise, I would give you a half mark if I saw that. Half mark for getting the t by itself, half mark for the numbers, and a half mark for the answer. Find M2. M2 is accelerating down, so M2G is the winner, tension is the loser. That equals M2A. Percy, how many M2s do I have? How many would I prefer? Let's get them to the same side. Swappy dance. I'll get M2G minus M2A equals T. What can I do now? Yeah, GCF. A great tool to have in your back pocket when you're doing something like this. I'll get M2 bracket, oh geez, that's messy. Bracket G minus A equals tension. So M2 is going to be tension divided by the bracket. You'll know you've done the Atwood machine ones right because it's either going to be tension over G minus A or G plus A, but I've never bothered memorizing what the pattern is. If you memorize the pattern, you go straight to the answer. In this case, Petco, I won't take marks off. I just don't memorize stuff that I can figure out in 2 seconds. M2 is going to be 48.36 all over 9.8. Take away, what was A? 2.6. Do you get 6.2? Sorry, 6.72. That's it, 6.2. 6.72, yes? 6.72 kilograms. So 2 out of 2 for that. Otherwise, I would give you a half mark for that. I would probably give you a half mark for that, half mark for getting the M2 by itself, and a half mark for the answer. A student of mass big M places a bathroom scale on a skateboard. So I guess I'm imagining scale on the skateboard, and then the student is standing on it. The student then rolls forward on level ground while standing on the scale. I think right now for part 1, the scale will just read M. I think. Now we roll the skateboard on a ramp, which is inclined at an angle theta degrees. What will the scale read now? What do you think? More than M, less than M, or M? Yeah. Convince me. Okay, I would give you full credit for that. So you heard what he said. He said, I know that when we're at 0 degrees, the normal force is mg. First of all, you mentioned, probably if I was doing this on a university exam, the first thing that I would mention is, I might mention that. I've taught and drilled you that, and so I'm okay with you assuming that I know that you know that I know that you know that the normal force is what the scale measures. So scale measures normal force. If you mention something about either that the normal force is decreasing, if you use that argument, I would take that. So you could say Fn gets smaller as, can I do a theta? Maybe I can. I don't have a theta ready to go. Let's find a theta in my more symbols. Forget it. I'll handwrite it. As theta increases, I would take that. Anybody else say anything else? If you did a free body diagram and you showed that with numbers that theta is, normal force is mg cos, and cosine is a decimal, so you're always going to be smaller than mg, I would take that. If you made up some numbers and just crunched the numbers and showed that the normal force got smaller, I would absolutely take that. Okay? So mark yourself a little bit generously there. But for 2 marks specifically, I would say, hey, yeah, remind me that scales measure normal force, and in this case, normal force is decreasing, therefore the scale is decreasing. Scale measurement is decreasing. Cool. Number 4, find the acceleration. This is a job for a free body diagram. M1G tension. Let's do it in blue, Mr. Duick, and components in red. M1G tension, M2G components, M2G perpendicular, M2G parallel, color, 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 color. Normal force, number 2 to go with mass number 2. Tension. Is there friction? No. Oh, for part A, no friction. Who's winning? I gotta be honest, at first glance, I'm not sure. But the tug of war is between M1G and M2G parallel. Those are the ones that are pulling on each other. So really quickly on my calculator, I'm going to crunch. And you know what? I could have also just said, since the heavier mass is on the left and it's getting all of gravity, it's going to be the winner. But okay, 8.8 times 9.8 parallel is sine. What's theta? 38. Yeah, definitely M1G is the winner. So, okay, who's winning? M1G minus tension plus tension minus M2G parallel. That equals M all of them times A. Oh, I've missed this. Oh, good stretch. Tension cancels. Any of you lose power yesterday? I was without power for about 2.5 hours. I literally plugged in my Instant Pot to cook my dinner, and as I plugged it in, so I guess I'm not eating for a while. It's a little grumpy. I was all hungry and Anyways, eventually it came back on. So I had some tension yesterday. How would I get the A by itself? I'm going to divide by M all. So I'll get A equals M1G minus M2G. Oh, 2 lines is sine all over M1 plus M2. Let's go to numbers. M1, 12, 9.8 minus 8.8 times 9.8 times the sine of 38. I didn't miss any G's, did I? Nope. All over 12 plus 8.8. I can type this in one line, I think. 12 times 9.8 minus 8.8 times 9.8 sine 38. There is a built-in error check. I know that A is going to be less than 9.8. Good morning, good morning. Welcome back. You get 3.1? And I'll keep this on my calculator. So if you got that, 2 out of 2. Otherwise, it looks like I did 4 lines. So I would go half mark if I saw that, half mark if I saw that, half mark if I saw that, and a half mark for the answer. We're marking our take-home quiz. You can just kind of pick up where we are. B, find the tension. Which mass would I use to find the tension here? Mass 1 or mass 2? I'd use mass 1 if I could, yeah, and I can. It's much less cluttered. So M1 is accelerating down, so M1G minus tension equals M1A. Swappy dance to get the T by itself. M1G minus M1A equals tension. So tension is going to be M1, 12, G, 9.8, minus M1, 12, times A. I'll write 3.1, but you know I'm using my answer button. You got a tension of 80.4? Yes? No? Yeah? 80.385, I'll go 80.4. And that's newtons. Here again, half mark for that, half mark for that, half mark for the numbers, half mark for the answer. Ooh, C. What would the minimum coefficient of friction need to be to hold the entire ramp stationary? I guess that means A is going to be 0. I guess I would need friction pointing that way. And so my equation now would be M1G minus tension plus tension minus M2G parallel minus friction equals 0. Equals M1, M all A, but A is 0. I want to find mu, which is hidden inside friction, so I think I would just plus friction to that side. Oh, and of course, tension cancels. I would get M1G minus M2G parallel equals friction, which is mu, that's friction force 2, times normal force number 2. How would I get the mu by itself? Divide by normal force number 2. I don't know normal force number 2. Oh, but look. I know the force the same size as normal force number 2, M2G perpendicular. Perpendicular? Of course I know the answer to that. So I think I can go like this. I can say mu, let's change colors, Mr. Duick. Mu is going to be M1G minus M2G cos theta. Nope, 2 lines is sine, Mr. Duick. All over M2G. Here's where the cos theta shows up. All right, I'm typing, but I can do this. Mu is going to be M1 12 G 9.8 minus M2, I can't remember, 8.8 times 9.8. You know what I could have done, by the way? I could have, if I'd been really clever, noticed that in this case the G's cancel, because there is a G in everything. Since I didn't notice that, I guess I'll commit myself to doing the extra typing and just going with it. Sine of, what was theta? 38. All over M2, 8.8 times 9.8 cos 38. I hope I got a decent answer. I was making up numbers. Do you all get 0.947? I've got a typo. 0.949? Is that right? People are nodding? Oh, okay. So 0.95, 0.949. So you need a pretty strong coefficient of friction. Remember the units for mu, there are none. So if you got that right, 2 out of 2. Otherwise, I would give you half mark for that, half mark for that, half mark for the numbers. Sorry, for that equation, half mark for the answer. Skiing. Oh boy, this is a fun quiz. They want me to find the coefficient of friction. Okay. Gravity. Components. mg perpendicular. mg parallel. Color, color, color. Color, color, color. Normal force. I guess friction is pointing up the ramp. Who's winning? mg parallel. Sorry, not M2, just mg parallel. Who's losing? Friction. What's that going to equal? ma. They want me to find mu. Mu is hidden inside of friction, so I'll get the friction by itself. I'll do a swappy dance. I'll get M2G parallel minus MA equals friction. Armand, friction is what times what? So this is going to be M2G parallel minus MA equals mu. You know what? Can I divide by the normal force right now? Because I'm trying to get the mu by itself. I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force. I keep writing M2 for some dumb reason. Why am I doing that? Doing the last question. I'll get mu equals mg parallel is sine minus ma all over mg cos theta. And you know what I've noticed here again? I could have, if I hadn't divided by friction right away, the m's cancel here too. Because there's an m and everything on the top, and m and everything on the top, and m and everything on the bottom. I could have done that earlier. Why can't I solve this? I need A. I don't have the acceleration. I need the acceleration to find mu. Or maybe they gave me enough information to find the acceleration. I don't know. So I'm going to say to myself, self, I need to fill in this blank here. Well, they gave me a time of 10 from rest. VI is 0. Oh, and 20. V final is 20. Oh, heck, I can find A from that. A equals VF minus VI over T. It's going to be 20 minus 0 all over 10. In fact, Kyle, I'll bet you can do that in your head. What's the acceleration exactly as a number in your head? Well, that was handy. So I can walk that over here. Now I'm good to go. Mu is going to be 9.8 sine, was it 12? 16. Minus 2 all over 9.8 cos 16. And again, if you left the m's in there, you'll get the same answer, not a problem. Bracket 9.8 sine 16 minus 2 all over 9.8 cos 16. Close off the bottom. Y'all get 0.0744? Or am I wrong? People nodding? Is that small? Oh, no. Are we skiing on snow? Should be a small coefficient of friction. Yeah, I'm okay with that actually. So 0.0744. I would give you, what was this one worth? 4 marks. I'll give you 4 out of 4 if you found that. Otherwise, I would probably go something like half mark for that. Half mark for finding A. And then 1, 2, 3, 4, 5. I don't know, something like that. 1, 2, 3, there's 4 marks. Can you give yourself a lovely score, please, out of, I think it's out of 29? 4 plus 4 is 8, plus 4 is 16, plus 4 is 20, 22. I don't think it's out of 29, I think it's out of 26, is it? 4, 6, 8, 10, 12, 14, 16. Or is it out of 20? Wow, I can't add. Let's try this again, Mr. Duick. 4 plus 4 is 8. Plus 4 is 12. Plus 4 is 16. Plus 2 is 18. Plus 4. It's out of 22. Wow, did I add that up wrong several times over? Is that right? Is that out of 22? Okay.